I'm astronomer Doug Duncan of the Fisk Planetarium at the University of Colorado Boulder. Welcome to Explorations, the series that takes a look into NASA's diverse projects and the people who make them happen. When we go out on a dark night, away from the cities and all their lights, this is the sight we see. The stars and the Milky Way shining as brilliant points of light. But there is more to this sky than your eye can see. This is the night sky in infrared light. By looking at the sky in the infrared, astronomers are able to see objects that would otherwise be invisible. Perhaps there's dust in the way, as in the dark clouds of the Milky Way. Infrared light can peer through the dust. Or perhaps it's simply brighter in the infrared, like some of the cloud belts of Jupiter, or some of the stars in Orion. Infrared can do this because it contains different information than visible light. One of these mugs, for example, is full of hot coffee. But we can't tell that just by looking because of their thick sides. Using an infrared camera, the coffee glows. The same is true for a jet. The heat generated by its engines can't be seen with visible light, but is stunningly obvious in the infrared. Astronomers, however, face a challenge when trying to see the universe in infrared. Not all light comes through our atmosphere. Infrared light has a longer wavelength than visible light and is easily absorbed by water vapor. Much of the Earth's atmosphere is water vapor, so while visible light has no trouble passing through it, infrared light is blocked from reaching the Earth's surface. Any telescope hoping to observe infrared light needs to get above most of the water vapor in the atmosphere, as high as 40,000 feet above the ground. Not even Mount Everest is that high. Meet SOFIA, the Stratospheric Observatory for Infrared Astronomy. SOFIA is a Boeing 747 modified to carry a 2.5-meter telescope high into the Earth's stratosphere. By observing in the infrared, SOFIA scientists are able to study how stars are born, the evolution of galaxies, the makeup of comets, and the atmospheres and surfaces of planets. It was observations from SOFIA that taught us about Pluto's atmosphere and how the Milky Way's black hole interacts with its environment. SOFIA is also known for the Airborne Astronomy Ambassador Program. Every year, groups of high school teachers join the scientists on a flight. These teachers will use their experience to inspire and teach their students about astronomy, the way that scientists do research, and about the scientists themselves.
The idea is that we want teachers to have a chance to see how scientists do what they do and bring that back to their classrooms. So it's not that we're trying to translate, frontier astrophysics into a 7th grade or a 9th grade classroom. It's that the teachers get to understand that science is a social endeavor and that it's a huge team that gets this all done instead of a mad scientist in a basement.
Giving them the background to the science behind SOFIA, the science of infrared astronomy, the science of spectroscopy. And they, all this time, have been communicating with their students who have been brought along in this adventure. And when they finish on this flight, and they're flying again tomorrow night, they will take this experience back to their classroom and live it again with their students. And it's such an inspirational opportunity for their students to be this close to a research environment.
The teachers not only get to ask questions of the flight crew and the telescope operators, they also get to look at the data themselves and learn how it's analyzed.
I just got done spending a lot of time with telescope operators. That was really neat. We got to do a Q&A with them for a good amount of time. and then they said, hey, you guys got to be quiet. Either get off the mics or you can pay attention. And they were super busy for about 10 or 15 minutes getting the telescope set up. And to me, it looked like they were scrambling around doing everything. And once they got off, they said, oh yeah, so that was a pretty smooth one. We handled that, no problem.
My background is actually in chemistry, and I love seeing how they're using spectroscopy in a totally different field. And it's just pretty awesome also hearing about all of the different people and all their different jobs on board, and how everyone had a different path to get them to SOFIA.
I did a really not traditional path into teaching, and a lot of my students are kind of lost and confused going into college in a year or two, and it's really interesting for me to see all these opportunities and kind of bring some of that information back.
So many different avenues for careers in something like this. There's just so many different careers, so many different levels of education. There's definitely something for everybody in a job like this.
I have been amazed to see the different paths that everyone has taken to get to where they are, and some of them are very traditional. You know, I was a kid and I liked space, and so I got a PhD in astronomy, and some of them were significantly less traditional.
SOFIA and the Airborne Astronomy Ambassadors are truly unique, providing students with a view of science that few get to see. One day, the students touched by this program may be the ones flying SOFIA, operating its telescope as they chase new knowledge across our night skies. On behalf of NASA and Fisk Planetarium at the University of Colorado Boulder, thank you for joining us for this episode of Explorations.